Welcome everybody. Today is September 12th, and we are going to be talking about Kubernetes hacking. My name is Jason Gillam, and today I'm happy to host one of our senior consultants, Cory Sabol. Cory has a background with hacking Kubernetes and containers and also hacking games. So I don't know if we're going to be doing both at the same time today, but that would be a very cool session if we ever did.
That is something I've wanted to do, is make a little like text RPG kind of thing that runs in a container. And what you're doing is trying to break out.
I think you should
part of the game.
So
never enough time.
Never enough time.
Problem.
No. It's all about priorities. There's never enough time for anything.
Fair.
So I'm going to just hand it over to you. You go ahead and jump in and show us what you got, and I'll probably ask some questions along the way.
Okay. Yeah. So again, I'm Cory Sabol, and this is Kubernetes Pentesting, the Hacker's Harvest. We've got about an hour, so I'm not going to be able to go through all of the cool little living off the land techniques that I've acquired over the years, but we're going to look at a couple of things that are good to know and to think about when pen testing a Kubernetes cluster. All right, and this is me. You can email me at Cory@securideas.com. I'm on Twitter. I should change that to say X, but it'll still go to Twitter. Fair warning, some of you probably heard this before, but if you follow me on Twitter, you're probably not going to get a lot of hacker stuff. You're going to get a lot of game dev and game art stuff, probably, because that's mostly what I do on there.
It's all good.
Yeah. So, I always like to start anything where I talk about Kubernetes or containers just with a quick recap or introduction into what it is, right? Just in case some people are not that familiar with it. So what is Kubernetes, right? Kubernetes, often abbreviated K8S. I pronounce that Kates. Other people maybe say K8S. I don't know. It's an open source container orchestration system that is responsible for providing automated application deployments, application scaling, automated application management, automated container lifecycle management, application health management, right? All of that basically means that it's kind of a pain in the butt to deploy and manage multi-container workloads. And so Kubernetes, in theory, eases some of that complexity and difficulty. But for those of us who've worked with Kubernetes enough, we know that sometimes it's very overly complicated.
It has its own challenges.
Yeah, definitely.
So before we move on from here, just because I just want to make sure everybody is up to speed on this. Like, if you've heard of Docker containers, like Docker, right? That's the I guess most common term to describe a container system.
Yeah.
What's the relationship between a Docker container and Kubernetes?
Yeah, so a little history, I guess, is Docker came along and kind of was the big player in containers, and they had their own runtime, right? Called the Docker engine, and that was what handled doing all of the low-level stuff for setting up a container and running it and whatnot. And the container being just sort of essentially a way of running a process or several processes in an isolated manner, such that they're isolated from other things on the system. Mm-hmm. Then, we sort of figured out, okay, it's useful to run, my web app in one container and my database in another one and have them talk to each other. And so we started building tools to orchestrate that. That's kind of where Kubernetes came into play. And so Kubernetes at its heart uses container runtimes like Docker. For a long time, they actually used the Docker runtime, but like 2 years ago, or maybe a little longer than that, the project switched over to running container D as its, I think that's correct, container D as its container runtime. But the thing is all of these runtimes are compliant with a standard called the Open Container Initiative. So they essentially work and behave the same, expose the same APIs, right? So yeah, that's an excellent question. That's sort of how that plays into this, right? So Kubernetes is going to be behind the scenes creating Docker containers, right? And orchestrating their lifecycle and interactions with them for you.
All right. Sounds good.
Yeah. All right. So we'll move on. Oh, and just that little note there. Kubernetes apparently comes from the Greek word for helmsman. I took that from their website a long time ago, and I've just been running with it. So
hopefully that's right.
Yep. So some terminology that also gets thrown around a lot when talking about Kubernetes that I'll use a lot potentially in this webcast is to start with, right, cluster, right? Like I'm going to be saying Kubernetes cluster a lot. So what is a cluster, right? Well, I mean, it's just a set of machines running containers, right? You can think of it as that. It's just it could be multiple VMs. It could be bare metal servers. It could even be other containers themselves because we can run Kubernetes inside of Docker containers and then run Docker containers inside of containers.
Container inception.
Right. But with Kubernetes, we have the concept of a node as well. That's just one of those machines in that cluster, right? Again, it could be a container, a VM, or a physical machine. And then we get to like some of the more weird terms, I think, which is where we have like a pod. That's a set of containers running on a cluster, right? So they don't even have to necessarily be running on the same nodes. It's just a logical grouping for a set of containers. Typically, they're going to be like the same container replicated, but they don't have to be. They could be different containers that just logically run together as part of the same pod, right? That's where you get things like sidecar deployments and stuff, right? Where you have maybe like your app, your API gateway server is running a logging sidecar, and that logging sidecar reads standard out and standard error from the app container and then does something else with it, right? Makes sense to have those together and whatnot. Then you have the concept of a deployment. This is just another sort of abstraction that Kubernetes has. This lets you specify like what containers to run as a part of this larger deployment, right? What service accounts to give the containers, what, potentially like what services they expose as well, which again brings us to service, which is another Kubernetes thing where a service basically is a way to describe how things can access your deployment, right? So it could be like you can define like load balancers, or you can tell Kubernetes to open a port directly on whatever node your deployment ends up on. That's not recommended, but you can do it. And then namespaces, which we probably won't touch on too much today, but namespaces are just, the definition of them is weird. It's virtual clusters in the same physical cluster. Yeah, so you think of it as like a namespace groups a broader set of these Kubernetes resources together, and they can talk to each other by default, and they kind of operate as if it's their own little cluster within your Kubernetes cluster. Namespaces are actually really important because a lot of Kubernetes security controls operate off of namespaces. One of my favorite ones, which is Kubernetes network policies. Those operate on namespaces. So having your workloads grouped with namespaces allows you to then essentially create like firewall rules, right, between them. You say, okay, my public facing app namespace shouldn't be able to ever communicate with the Kubernetes API, or my CI/CD namespace, right? You can block that off, but the CI/CD namespace can maybe communicate into that to deploy things, or to monitor, if you have like monitoring and things like that.
Oh, okay. So it sounds like it's similar to like segmentation and its concept, like network segmentation.
Yeah, the network policies are, but the thing is like,
but you can do other things with them too, I guess. Namespaces.
Yeah, so namespaces themselves are essentially like just a label in a way. And so, you can start to build things like your security policies. So Kubernetes has security policies that let you define criteria like pods can only run if they aren't running as root, if they're not privileged, right? You can deny things like bind mounts. You can do all kinds of stuff to harden those workloads. And those can also key off of namespaces too, right? So you can apply those to specific namespaces.
Okay.
And then of course it also just logging will show you like, oh, this was from this namespace, or et cetera, and things like that.
Cool.
Yep. This I like to show a lot too when we're talking about attacking Kubernetes, because MITRE and Microsoft collaborated a couple of years back to create an attack matrix for Kubernetes. This one's sort of maybe the latest, probably, I think this is the latest update. And so some things were kind of removed and some things were added here in green, right? But if you're familiar with the attack matrix, right, you have your initial access, your execution, persistence, privilege escalation, defense evasion, yada, 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 right? Pardon me. Good way to categorize, tactics and procedures, or, exploits and things of that nature. Especially if you're threat modeling, right? It's a nice way to sort of think about it. We'll kind of be looking at some of this. We're going to assume in the demo that I'll do, we're going to assume we've already achieved initial access, right, through like an application exploit or something into a container on the cluster. And then from there, we're going to look at some of the ways you could you could live off the land and use what's available to try to pivot and escape essentially from the cluster. So that would be right execution, and then probably privilege escalation and lateral movement, right? As you know, when you try to categorize security things with these neat little boxes, you can't really fit them, things into one, right? There's a lot of overlap.
Yeah, I noticed there's quite a few more new techniques than there are deprecated techniques.
Yeah,
an indication that containers are, I guess, a big target.
Yeah, exactly. Because again, this is made from Microsoft runs Azure, and so they have hosted Kubernetes services, and they see a lot of traffic and analyze it, and so a lot of this comes from that sort of data driven approach of what they're seeing and whatnot. As always, credential access for any kind of IT system is always still a big a big problem, right? It's a challenging thing. Let's see. Yeah. Okay. Yeah. So what we'll do is I'm going to go ahead and kind of work through a demo here. And so our scenario that we're going to assume, pardon me, is that we've already landed a shell, right, in a container via, I don't know, like an application exploit of some kind, right? It was running, maybe we were on the internal network and we were able to get to it, or it was publicly facing and we got to it, or, something of that nature, right? Just, we've already gotten into a container in the cluster. And so, we want to think about some reconnaissance scenarios here too, right? We're in there, we want to try to pivot around and whatnot. But, if we are pen testing in a scenario where, for example, there's runtime protection enabled, like with Falcon, or I think, what is it? Wiz has it, right? There's plenty of other ones that detect things like container drift, where, if a new file is created in a container that wasn't specified as a part of its initial specification, that can trigger alerts, right? Things like that. And I should change that to not say dev TCP. Should change it. I meant to say curl, because we're going to abuse some existing binaries as well. Although we could use dev TCP, but there's some tomfoolery involved with trying to navigate SSL against the Kubernetes API. That is not fun. So that one was biting me. But I'll still show that, because I think it's an interesting thing to look at as far as when you're trying to create a minimal container image, for example. And then so we'll use that, we'll use curl in this case to talk to the Kubernetes API from inside the cluster to try to gather more information, right?
Okay.
And then our exploit here is what we're going to do is we're going to use curl again, right? But we're going to use an overly permissioned service account to try to create a new container with some things in it that lets us, right, try to escape to the host, right? We're going to try to break out of the cluster.
Yeah. That sounds good. So one question I have right before you go into the demos.
Yeah.
How contrived are these? Like, I know there's going to be some things that you're going to say, okay, well, let's assume this and let's assume that.
Yeah.
But compared to when testing that we've actually done, does this how prevalent are these?
Yeah, that's a good question. I think in my experience, it's gotten harder, right?
Which is a good thing.
Yeah,
that's what we hope for, right?
Exactly. So it's gotten harder, but I don't think none of this is really out of the realm of possibility, right? It's assuming that access is probably the biggest leap in logic, right?
Yeah.
Because unless you've we could have taken a totally different route here and said, okay, let's assume we compromised some developers or DevOps person's credentials to access Kubernetes, right, and do things against it. And then we could use the kube control command line tool to go at the cluster, right, as well. But a lot of the ideas are similar. It's just the mechanism by which we'll do them is different. And so, for example, I've on a pen test before been in a similar scenario where I had execution in a container in the cluster, and but I couldn't like download any new tools or anything, right? So I had to leverage Bash's built-in dev/TCP.
Just what's there, yeah.
Yeah, to essentially, I built a little web server out of Bash and dev TCP, so I could infiltrate kube control into the container and then have an easier time with trying to enumerate things and move around. But again, things like drift protection would probably detect that, right? Like I've had that actually happen where I pulled in kube control into a container I was in, and that's triggered an alert, right?
Sure. Yeah.
Whether that alert is being monitored properly and keyed off of is a different story, but
yeah. And then you have a similar challenge, I guess, to just getting past endpoint protection in a regular pen test, right?
Yeah. There's a lot of parallels there. I think there's more. I think in this scenario, there's less, I guess, wiggle room to some degree, right? Because we're more isolated.
Is that just because containers are usually much better defined than somebody's workstation?
Yeah, exactly. And so, there's also, right, you have sidecar containers that are monitoring the containers as well. And so if I don't have the ability to do something to that sidecar container or modify it, using the Kubernetes API, then I'm reliant on, okay, is there a vulnerability in it or something that's, and then so it starts to get, right, it just starts getting where it's like, okay, this is probably not going to work out. Yeah.
Cool. All right, well, let's jump into some demos, and then I guess afterwards we can talk a little bit more about what can people make sure that they're doing to avoid these issues.
Yep. All right, I need to make this bigger. I've got a lot of JSON going on here. I'll clean this up a little bit, and you might see me fumbling about with my tmux panels here as well. But what we want to do here is let me do this. Okay. So what we're looking at here is we're going to assume that we've already gotten access to the container. I'm in one right now running in this pod manager deployment, whatever that may be, right? It's not uncommon to have containers and stuff that do things to other containers, right? And so we're in here. We want to, see what we've got available to us. And so, right, one thing we might look at is, actually, I think I need to make this bigger. I'm going to do this. There we go. Right, we'll just do ls, right? We want to look around and see what tools are available to us, right? So we might look at /bin, see what's in here, right? see if we've got anything, I guess, interesting or useful, right? Like curl, if curl's in here, that's a good one. Another thing is I can just do which curl, right? So that one's actually under user bin, right? So we might also look at user bin, right? We see what's in here. Again, what we're looking for is anything that can, in this scenario, what I'm looking for, I guess, is any sort of tool that's already in the container that's going to let me like make HTTP requests, right? So if Python were in here, right, which it's not, but if Python were in here, that's also going to allow me to do what I want to do, right? Because I can whip up some Python that's going to then, communicate with the Kubernetes API. And I don't necessarily have to like create a new file on the file system, like, hack.py or something, right? Again, if I'm trying to make sure I'm not triggering drift protection, or drift detection, sorry. You could do Python, right? If you're familiar with it, right, you can run Python and just run the snippets like inline here,
Yeah. Or open the Python interpreter and just,
or do an interpreter. Exactly. Yeah. So those are the sort of things I'm looking for, right?
So a question, and this is a leading question because I think I know the answer already. Like, if you're already familiar with Linux environment, why do you need to go through the effort of looking for things that are normally there?
Yeah, that's a good question. Right. So with container security, with containers in particular, we have images, right? And those images are the snapshot of everything that container is then created from, right?
Yeah.
And that image contains essentially everything that is necessary for whatever workload you need to run in that container to run, right? Yeah. So if your container runs a Python app, you're probably going to have Python in there, right? Unless you're doing like C Python and you've compiled it, and whatever.
Sure.
And so the thing is when creating these images, there's a concept of creating base images, right? So you want to create an image that your deployments are built off of. That base image should be minimal, right? In that you want to have only the things necessary to accomplish your goal in there. So, for example, I'm looking for curl, right? Curl is not installed by default in the Ubuntu Docker image, right? Which is what we're using here. So this means it was installed by someone. It was installed by me, but it's in here for whatever reason, maybe some debugging purposes or something, right?
That would be that's a good one because that's a common library that people would say, oh yeah, I need to pull something in or I need to do something. It's not, curl's not here. Let me go ahead and install it.
Or wget is a common one as well. Right. So tools like that you maybe are already familiar with just from doing, Linux command line stuff here and there and pooling, things and whatnot.
Yeah.
So again, the reason we have to look for those is because we can't assume that they're in here, right? And ideally they shouldn't be in here. So we're looking around for anything that kind of lets us, weasel our way into doing more than we should be able to.
Right. And because it's very common in container images that depending on, I guess, if they're following best practices when they're building them, whoever's building the container, the base image,
right,
it should be restricting very much what's in there to just
the
bare minimum that's necessary to run the app.
Exactly.
But often people don't do that.
Right.
Very, very often people don't do that.
Yep. Another one that is kind of a sneaky one is OpenSSL.
Okay.
So OpenSSL can be used to make network requests.
Sure. Yeah. You could build a tunnel with it.
Yeah. And so but it has this built-in S client, right? Which you can use to, it's a pain in the butt to get it to ignore self-signed certificates though, which is the issue I was running into with it. So the documentation's I don't know, inconsistent, it seems, with whatever version is installed here. So that, I mean, that's right. That kind of shows, right, like we have that in here, that kind of shows the challenge too of trying to you know, make sure you're building secure images, right? And so rather than, you know, thinking, I guess, in a denialist approach, I think, right, is what I'm trying to say. Yeah, rather than thinking like a denialist approach, right, in this case you want to kind of think in an allow list approach. You're only allowing exactly what you know you need in there, right? And anything else that's not crucial for operating doesn't need to be in there. So in this case, also, like the OpenSSL package doesn't really need to be in here.
So I might be getting ahead of myself just a little bit, but because I know you have some demos you want to show, but
yeah, it's fine.
Just jumping into a quick question here on this, because I'm less familiar with hacking Kubernetes than you by quite a bit, but I am familiar with developing containers. And so there's this when you're building a Docker file, one common thing to do with that is to do multi-stage builds, right? So you start with, because you may need a lot more tooling in the container to actually compile and get your program ready than you actually need in your final container. And so you'll do a multi-stage build, which basically lets you throw away the things that you needed to build your solution and just keep the things that you needed at the end. Is that something that would be a recommended approach for building more secure containers as well?
Yeah, absolutely. I think so. Because with multi-stage builds too, you can have different images, right, in each stage as well. So you would still want to have that final, for example, the final image that you know is going to be actually running your software. You'd still want to make sure you're using a minimal image that you trust, right, for that one. But exactly, like I think a common approach would be to just take that base image and install all the build tools you need and like build the thing and then, have it there to run. And that's the image you commit. And so now it has all these build tools in it, right, as well. And it's running in your cluster. Whereas with the multi-stage, right, you can, again, switch that context after you've built it, pass the files to the new secure, minimal image, and only have what you need to actually execute the software.
Right. So you could have like a golden minimal image that you use, and then
exactly,
and then you only install that. Yeah. Okay.
Yeah. Exactly. And so that works again. Yeah, that works really well with multi-stage builds.
Yeah.
So cool. That's an excellent addition or question. Was it a question? Yeah, it was a question.
It was kind of a question. Well, it seemed like it would fit, but it was just
I mean it makes total sense. I mean, we're talking about images and unnecessary things in here. One of them that's a little harder to get around is the fact that Bash, for example, has /dev/tcp, which
you did /des.
Oh, I did. Yep. Built into it, and UDP as well.
Yeah.
But basically, this is a Bash built-in that lets you make TCP connections to things, right?
Okay.
And you do it like it's like IP address would go here and port would go here, and essentially this is just a special device is how it acts, right? So you can pipe things to it, right? So you would do something like echo, I don't know, HTTP, right? Like I'm not gonna actually write out a HTTP request here, but because that should be
okay. So you could actually write out your HTTP headers.
Exactly. You could write out the like HTTP headers in a raw request in your terminal here, and then pipe that into dev/TCP, point it at a web server, right? And then it's going to spit whatever the response is just back out. So you do have to do some bash, bash foo around it to get that to work nicely. But again, that's something I've done on a pen test before, where like I hacked that together so I could then essentially infiltrate kube control into the container so I could have an easier time.
So you're essentially proxying through your wherever your entry point is.
Yeah,
To get to other things. Yeah.
It's just like we've done before, like using Python to build a web server in Python to pull in other tools, right? To infiltrate things or to exfiltrate things, right?
Yeah.
Could go the same way. Yeah. So I mean, that's all just right. Why we would look around and kind of see. We'd want to see, right, what is here for us to play around with.
Cool. All right, let's see some hacking stuff.
All right. So what I've got here, our scenario that we're going to do here is what we're going to do is, when we're in the container here, right, there's a lot of information available to us that is, sort of the same information that we would get from, say, like kube control. So like if I go over here to my host and I do like kube control, get pods or something, right? It's going to show me what pods are running. It's a little, the output's a little janky, but that's okay, right? Or kube control get deployments, right? And now this is only working because, again, this is on my host system, not in the container over here, where I have kube control. I have a kube config file that has an account associated with it that gives me, cluster admin and everything, right? So I can do whatever I want. Yeah, so to kind of illustrate the point of what I'm going to, abuse here with curl is that Kubernetes is entirely API driven, right? Everything it does is orchestrated and communicated over RESTful APIs. And so there's the Kube API server, in which we can actually look at that. Get pods, we'll do get pods, and then we'll do, we'll say namespace. I think it's kube system, right? Okay, well, we're gonna see. Okay. Here we go, right? So here's our API server, right, running Kube API server, Docker desktop, and that gives that away. I'm using Docker desktop to run this Kubernetes setup. Right, you can see the DNS services that Kubernetes uses to allow other services to discover each other. Right, the kube proxy is a big one because that's what allows requests to go from the external API endpoint to the internal one, and various other things such as routing. Like if I did kube control exec and I wanted to attach to a running container with a command, right, that would go through kube proxy. Okay, so all that is a bit long-winded, but what essentially what we can do is, these containers also, a lot of times, they need to be able to talk to and know how to, where the other services are, where the kube API is and stuff. So one thing to also just recon once you get into, if you're in this situation, is just look at the environment variables, right? And we're going to get a lot of junk here because the output's all zoomed in, but let me do this and we'll scroll around real quick. Scroll up a little bit, right? Well, actually, here's some interesting ones right here, right? We've got Kubernetes port, right? But this one in particular, Kubernetes service host, that one's really useful to us. And Kubernetes port, right? And that one's really useful to us. And I mean, none of this other stuff's really that useful to us, but also you may find API keys or, credentials or just other useful information in here, right? It's kind of the same thing you might do if you run a network pen test and you got onto a Linux server or something or another server, right? You want to also look at the environment and see if there's anything sensitive in there that you can use. So we're going to look at that. And since these are defined as environment variables, I've already kind of hacked together some curl commands that are going to let us examine information about the cluster. And I'll show you these. Let me jump over here. Oops. There we go. All right. And then I'm going to control BZ this. So what I want to do is I'm going to, let's see, let's look at, let's do Vim deployments. Look at this one real quick. So we're going to run this in our container that we've compromised, right? So to speak. And what this does, though, and I'll make this a little bigger again as well, just because, right, we're just defining some variables in here, right? We're going to define some variables, and we're going to read, from those environment variables we looked at, right? We're just going to read that Kubernetes service host variable and that Kubernetes service port environment variable. So we already know now our little command knows, right? We've already built our URL for talking to the API.
Mm-hmm.
This is one that I will show you, and we'll talk about before I actually kind of go through it. But we're going to grab a token as well. And the reason we're going to grab that token is because in Kubernetes, every container by default has a service account associated with it, right?
Mm.
And a JWT gets injected into that container under that path, right? var/run secrets Kubernetes IO service account /token.
Oh,
that token can authenticate to the API, right? So it's also really important to be careful with your service accounts that you provision. Kubernetes has role-based access control, and we'll look at some of that as well. And so this token can also be used. I don't really have time to go through it, but we could use that token, and there's an endpoint on the Kubernetes API that lets us ask what a token can do.
Okay.
So we could take that token and say, okay, hey, tell me what is this capable of? And we might see like, oh, it can create new pods or, list secrets or something, right? And then so we're like, okay, now we can abuse this token further.
Okay. Yeah, that sounds like a very useful recon piece once you get that first.
Right.
Right.
Exactly. And then the thing is I said by default, there's a service account token in there. And if you don't specify like what service account the containers or the pods would have, they will get the default service account, which by default, I keep using default, but by default doesn't have any real permissions, right? But a thing I have encountered on pen tests is the default service account is given additional permissions, right? And so that can lead to escalation paths that may have not otherwise been there. I've been able to take that before and escalate to be able to do, I don't remember exactly what it was, but essentially I was able to kind of jump through some hoops to create a new service account that let me then create new containers from the default one.
There's a question in the chat.
Yeah.
Okay.
So Fausto asked, can we query that service if exposed externally, like for the token? So yeah, so if we have the token, right, and we're not in the container, if the Kubernetes API endpoint, on the master node is available on the internet, right, or available on your internal network, right, I'm going to take external to just mean external to the cluster, right? Yeah, we could still query it, right? In fact, kube control itself has a flag that lets you specify what token to use. So you can give it a token, right? And so I've done that, right, where like in one of my classes on Kubernetes Pentesting, we do that same thing.
So it runs outside of the container, the cluster.
Exactly.
Yeah.
Exactly. And so, and because it has to, because otherwise you wouldn't be able to actually access the cluster to do anything. So that's important to protect, right, the Kubernetes API endpoint.
Now you would still have to get the token somehow, though, because in here you picked up that token from on the local file system.
Exactly.
Already compromised, right? So I just want to make sure that that's clear.
Yep.
That you can't, like, you can't just call the API without first having the token and then.
Right. Exactly. You do have to authenticate to it, unless for some reason you've configured it to not have authentication. But
that would be really bad.
Yeah.
It sounds like it.
And the thing is that most from what I have seen, most organizations are using Kubernetes like as a service, right? Like a hosted cloud provider like Azure or AWS or Google Cloud, right? Those have a lot of I guess you could say, best practices in place already around aspects of managing the Kubernetes API and stuff like that.
Okay.
It becomes hairy if you're going to like deploy your own Kubernetes cluster, from scratch and manage that. Then it starts to get a little scary. But yeah. So another way to potentially get those kind of credentials, though, is again compromising like developer credentials, right? Like a kube config file is a file that kube control creates on the file system that maps to credentials, right? So those are also sensitive. Yeah. So, and we're going to do some more stuff here where we're going to read the namespace, which is, again, I mentioned Kubernetes namespaces. This namespace in this example is just going to be default because I just deployed everything to the default namespace. But that's also information you can recon from within side of a container in the cluster, right? And then we're going to run curl. And this is a pretty straightforward curl command, right? We're going to give a header with our authorization header, the bearer token. And we're going to use that token that we're going to extract from this container's file system, right? Specify our content type, use our API server endpoint, right, that we put together. And so that defines, right, under APIs, we can look at apps, v1 namespaces, we specify our namespace, and then deployments. That's going to let us see what deployments exist in this cluster in that namespace. And that's useful for us in this case because of what we're going to try to do here in just a moment. So what I'm going to do is I'm going to jump over to this one here. And so we're going to grab that command. And actually, I think it would be cool to show you that token real quick. I think it's secrets, Kubernetes IO, what was it, / service account token, right? So we can see we get this token here, right? And it's just a base 64 encoded, JWT. This token itself is also useful to look at the claims of the JWT because you can glean some information from that too. And I don't know if base 64 is installed on here or not. Ooh, my output's getting all screwed up. Let me do that. There we go. Okay, yeah, so it is here. So what I can do is tac D. And that's going to mangle some of it because of the signature and whatnot. So I could split it on the period and whatnot but I'm not going to do that. But right, we could grab that middle section and decode it and then look at the claims and see what service account. That actually will tell us what service account this is as well, like the name of it and whatnot, which is, again, can be useful information because if it's something like deployment manager service account, then as a pen tester, I'm going to be like, well, that sounds like, pretty juicy, right? Okay, so let me grab my command because it is, where did I put it? I have it where I can copy it easily somewhere in here. Let me go back to, I'm gonna have to do it like this. Maybe using tmux was not the best idea. No. Got them all out of order. There we go. Okay. So I'm gonna actually quit that and cat it because I don't trust Vim sometimes to output things nicely. No. There's another little thing I got to do because of tmux. I got to zoom it in so I can copy this correctly. All right. And now what I'll do is Control DZ, and I'm going to paste that in here, and then we'll just run that, right? And then we get this big output of, junk here. We might have less. That might make it easier just to look at this, right? Okay, no, that didn't work. That's okay, because what I'll do is I'll just go into scroll mode. So what this is a response from the Kubernetes API, right? And this is telling us about all the deployments in the default namespace. There's only one right now, and it's the one that we are in a container for.
All that information's from one.
Yeah.
Okay, I just making sure. Yeah, it looks like there's a lot of info there.
Yeah, so we got the deployment list and then items, and then the deployments themselves will be in here, and then the deployments have a lot of information associated with them, right? The main thing we care about in this case is this pod manager deployment, right? I just want to know the name of the deployment, because what I'm going to do is I'm going to try to, after this, I'm going to try to abuse this token to deploy a new container, right?
Hmm.
And a step that was kind of omitted here, but that we probably want to do, right, is again use the API with that token to see what it can do. I might have that laying around actually. I have like a repository of these kind of commands. But we can see all kinds of stuff in here, like what image is being ran in the containers. That's also useful information, right? Because in terms of staying hidden or stealthy, right? Ideally, what we'd want to do is use images that are already in use, right? So they don't stand out, or we don't have to pull a new image, right? Like if the cluster already has it cached, it will just use that cached image, right? So we're not creating unnecessary network traffic potentially. So that's another thing to kind of think about. We could even go into as far as to like start trying to inspect these images and see like what's inside of them, right? There's ways to do that as well. Before I continue, I guess a point that I should have illustrated or made earlier is that when you're interacting with like Docker and Kubernetes with their command line tools, all they're doing behind the scenes is translating your flags into an HTTP request and sending that via HTTP to a REST API. The Kubernetes API, the Docker engine that runs the containers, it also exposes a REST API, but over a Unix socket. So it's a little, but you can still interact with that with curl. So this stuff is just going one little step deeper behind the tools and saying, okay, this is just what the tool is doing, right? Essentially, it's just querying these endpoints and grabbing information out of them. And so we can do that too. So yeah, I wanted the deployment name, which was, that's what I really wanted here. Got to keep scrolling. Pod manager deployment, right? So that's easy enough to remember, I think. I hope. So what I'm going to do now is I want to, I'm going to go back over to my scripts here. And I've got a command here that is designed to try to deploy a new container. And the way it's going to try to do it is by patching an existing deployment to add a new container to it. And so what I'll do is I'll show you in a second the service account and why I'll be able to do this. But I've got a little bash reverse shell in here. Again, here's our friend dev/tcp, right? This is one of my favorite reverse shells. It's pointed to my host netcat listener. You wouldn't really want to name it this if you were trying to remain stealthy, but I'm going to do it anyways because this is, but we're going to use Ubuntu. What we're going to do is we're going to try to run it as privileged. We're going to create a volume mount under /mount that is a host volume, and it's bidirectional. That means we'll be able to manipulate files on the host file system that this container is running in. And then we're going to make it, again, we're going to do a similar thing. We're going to use curl to make a API request to that API endpoint. So what I'm going to do is I'm going to see if I can copy this nicely from here. All right, and then see if that will let me. I might have to cat it. Oops. Oh no, my Vim. There we go. All right, let's see if we can get in here and do this real quick. Is this that? See, it didn't copy. That's the thing that's a little annoying sometimes. I don't have my Vim set up nicely on here. All right. Gonna have to do it a little differently here. Just a second. All right, let's get rid of that. Let me go. We might. All right, let me go here. Control PC. I'm gonna just make this small so I can copy the whole thing in one swoop. All right, there we go.
Yeah.
All righty. Now I'm gonna go back to this guy over here and make it my main panel. Let's zoom it back in. And then paste all of that, and hopefully that works. Okay, so we got what looks like a success output. So again, this is telling us that it's like now creating this deployment, right? It's creating it. It's adding it to our pod manager deployment. Yeah, lots of stuff here. Trying to find. Yeah, okay. And then that was our payload. I want to make sure that worked. Let me see. If it worked, then I should have I don't. Dang it. I'm going to say if it worked, I should have a shell connection over here. I don't think that pasted correctly. Let me see here. This is one of the troubles. So this is why, I kept mentioning how I would go through great lengths to just infiltrate. Cube control. Yeah, because it's kind of a pain in the butt to do all of this.
Do it manually.
Yeah. It gets a little janky. Okay, so we've got that there, and then my listener is here. Okay, so the command terminated with an exit code. Why did it terminate? All right, so I'm going to do it a little differently here. I'm going to
give it one more go. We're running a little bit low on time.
So. Yeah, I'm going to give it one more college try, So let's zoom this in. I'm going to just do export. And then I'm going to paste this here and make that an environment variable. And then I want to do, where's my $sign? There we go. Patch. I guess my tab completion doesn't work in the container. No, an option. Oh, okay. I see the problem. I surrounded. I got my quotes backwards in my payload there, so that might be there. I think it's expanding. Let me do this again. All right. No. Oh, it looks like my. Okay. I see what happened. My whole container got killed by that borking.
So the container's off.
Yeah.
Yeah.
Let's try this. Let's do kube control get pods. It says it's running though, but it's only running the one container, so it broke my connection to the container. It looks like. Let's see if we can get back in there. Yeah, there we go.
This is always that risk with the live demos, right?
Yeah.
It's like, that makes it fun too.
Right, let me try export. See, I don't know if I can change my. You know what I can do? Maybe. Is it single quotes or double quotes? I can't remember which ones expand. Let me. I think it's
for the audience.
I think it's double quotes. So I think I might have this actually correctly. Let me do this again, and then echo it. We know it's in there. And then let me try the deployment again.
Single quotes is usually literal string.
It. I guess it restarted the container, so I'm gonna do just for the sake of it.
Oh, okay. So curl's not even there anymore.
Yeah.
Whoops.
Yeah. Dang it. I'm probably caught. Hopefully by now, right? Okay. Let's try that. All right. So now what I want to do is I'm going to just check it. I'm going to sanity check it. From here using cube control. Well, now what the heck? Okay. I don't know. I don't know. I don't know why that didn't work.
It happens. It was working before. Trust us.
Yeah, it has. Yeah. So I don't know. I don't know with that.
I think that the point though is well received, which is you have access to a lot of capabilities through this API.
Yeah.
And it's trivial once you get onto any node inside of a cluster, and Kubernetes cluster is trivial at that point to get an API key that you can then use to potentially pivot all over the cluster or spin up another container or do all kinds of things with it, even if you don't have kube control directly, because there's usually something else you can use to make web requests. Does that summarize it?
Pretty much. Yeah.
Cool. We're about out of time, unfortunately, and I know you probably had more things to show, so we may have to do a second edition with working demos. So, but I think this was really cool. I actually learned a bunch from it as well, and I hope those of you watching did as well. Please join us in the next few weeks. We have a couple more really cool webcasts coming up. On the 26th, we have the Many Hands Approach to AppSec with Mick, and Eric will be hosting that one. Mick is pretty awesome at AppSec. He's especially well known for hacking front-end stuff, so all the JavaScript and that sort of thing. And then in October, we have a couple of webcasts. One is the CISO's Myopia with one of our newer consultants, Jordan, who he wrote a blog post on this recently, and I believe he's going to go over more of his same thoughts there. And then on the 24th, we have from Kathy and Aaron, our resident horror flick
enthusiasts,
fanatics, I guess. Yeah. Trying to look for the better term, are doing the haunting of the dark web. So we'll be talking about the dark web and what's in there. So that should be really cool. It's on October 24th. So thanks again for joining. As usual, Cory, it's a pleasure. I always learn something when I get on a webcast with you. So very cool.
Yeah, thanks everyone for joining. Sorry that last demo broke.
It happens.
Yeah, it does.
We'll do the next one.
I didn't make my my offerings to the demo gods.
That must have been it. That must have been it. So if anyone has any questions, go ahead and shoot them over. Probably through email is easiest at this point.